Assalamualaikum and good morning everyone. Let's continue our quantum chemistry lecture with normalization, okay? Some of you have asked me, how do you know whether a constant is a normalization constant? Let's look at, for example, if you are given a wave function, psi e to the power 5 ax, a is a constant, but it is not a normalization constant. Why? Because if you want to know whether a constant is a normalization constant, you should be able to multiply the wave function by a constant, okay? So if you multiply, for example, if you have a constant, multiply by the wave function, you should be able to get a constant, okay? Multiply by e to the power 5ax, okay? And then you can label this constant n. I normally use n, okay? In this case, n is a normalization constant. Okay, but a is just any constant, okay? A is not a normalization constant. Okay, let's look at another example, okay, as to make it clear to you. For example, if I give you psi x equal to sine bx, where b is a constant, okay? But you want to know whether this b is actually a normalization constant or not, okay? You try to multiply the whole wave function by a constant, okay? So if you have a constant, multiply by the wave function, okay, and then your wave function is sine bx. So if you look at this wave function multiplied by a constant, you immediately know that any constant, normally I use n, okay? Any constant multiplied by the wave function, this constant is actually normalization constant, whereas b is just a constant, okay? It is not normalization constant. Why? Because you cannot multiply wave function by a constant for this function, okay? So it is really easy if you want to know whether a wave function is whether a constant is a normalization constant or not, okay? You make sure that you can multiply that wave function by a constant, okay? And then n. So I hope it is clear to you whether a constant is actually a normalization constant or not, okay? If your wave function does not have a constant, you should multiply it by a constant, okay? In order to get normalization constant. Okay. Because if you look at the Schrodinger equation, okay, if you are interested to know why you multiply a wave function by a constant, it does not change the mathematical structure. If you have a Schrodinger equation, h hat multiply x on wave function psi x, it gives you e multiplied by the wave function itself. Okay. So for example, if you have any wave function, okay, you multiply it by a constant and it still does not change the solution to the Schrodinger equation. Okay. For example, if I have h hat, okay, it acts on constant multiplied by the wave function, what you get is just e, the constant multiplied by the wave function. But because n is just a constant, you can take out n, okay? So n can be here, and then you have Hamiltonian operator act on wave function equals to n, okay? You can pull it out, okay? This is just e is just eigenvalue, so it doesn't matter about the order. Multiply by multiply by e, and then multiply by the wave function itself. If you look at this Schrodinger equation, you should know that you can immediately cancel n. Okay. So and then you are left with this Schrodinger equation, because you already cancel n. Okay. So that's why wave function is a solution to the Schrodinger equation. But if you multiply this wave function by a constant, that constant, okay, that constant multiplied by the wave function is still a solution to the Schrodinger equation, okay? It does not change the mathematical structure at all. That's it. Thank you very much.